Okay, Mr. Olumide, you can begin.
Yeah. Yeah. Good afternoon, Solomon.
Yeah, good afternoon, Mr. Olumide.
Yeah. How are you?
I'm doing very well. Thank you very much.
Yeah. I will be taking you in chemistry. So, as you can see from the slide, the topic we are doing today, the first topic in chemistry, that's matter and separation techniques, particulate nature of matter, basic chemistry, chemical combination. These are the 4 places I will be taking questions from. So we'll be answering Jamb question from 2021 to 2016.
All right, sir.
Yeah, on this first topic. So let's go to the next slide where the topic starts from. Where is the question start from? Yeah, the first question, number 1. Which one of the following is not a mixture? Which one of the following is not a mixture? Now, in the first topic in chemistry, we talk about mixture, element, and compound, where element is defined as a substance that cannot be broken into any smaller one. A mixture is combination of elements or compound that are physically combined together. That means you can separate them. For example, if I have my pot of soup, in my pot of soup there is meat, there is pepper, there is salt, which I can separate at the end. So that is a mixture. Then we have a compound. Those are elements that are chemically combined together. Example, you have your H2O, which is combination of hydrogen and oxygen. Water you cannot separate. In a water, you cannot separate the hydrogen from the oxygen. You get by ordinary physical method. So anyone that you can't separate is a compound. Anyone you can separate is a mixture. Why the least element that you can divide to is a mixture. So we have this now. They say which of one of the following is not a mixture? That means the rest are mixture. It's not a mixture. That means the rest are mixture. A, air, B, mercury, C, milk, then D, cement. They say which one of the following is not a mixture? A, air.
Sorry, am I to answer the question?
No.
Because I think the answer should be mercury, because mercury is an element, while air is a mixture, milk is a mixture, and cement is.
Good, correct. That's good. So the answer is mercury, because mercury is what? Is an element. Why air, milk, and cement, they are mixture. Very, very correct. Good of you. Let's go to number 2. Oxygen is absent in the following. Oxygen is absent in the following. Now, we know that oxygen is O. And we know it can combine with itself to become a molecule of oxygen, and it can combine with many other elements to become a compound. So A, we have kerosene. B, we have soil. C, we have glass. And D, we have cement. So they are asking which one is absent of oxygen. So the answer is kerosene, A. Why? Because kerosene is only hydrocarbon. You know what hydrocarbon is?
Yeah, certainly. Hydrocarbons are combinations of carbon and hydrogen compounds in organic chemistry.
Yes. So so there's no oxygen in kerosene. A kerosene is an hydrocarbon compound. So it's only having carbon and hydrogen. So the answer is kerosene. Soil is having oxygen. Glass, SiO2 is having oxygen. Cement, CaCO3 is having oxygen. So the answer is A. So let's go to number 3. Question number 3. A sample of any of the following substances disappear after some time when exposed to air, like camphor, naphthalene, or dry ice. This phenomenon is called. Now, in chemistry, we have 7 phenomena of change of state. We have from solid to liquid. When your solid is changing to liquid, when your liquid is changing to gas, and when your gas is changing back to liquid, and when your liquid is changing back to solid. So when solid, if you are, for example, you have your ice now, you want to change it to ordinary water, what are you going to do?
You apply heat.
Yeah, you heat it. So that's melting point. So melting point is between solid and liquid. Why? If you want to make your liquid to become gas, what will you do? You still continue heating it and it become what? Boiling. We have that, we call it boiling point. Now, if you want to change your gas back to liquid, that's condensation. And if you want to change your liquid back to solid, that's freezing. Do you get that?
Yes, certainly, I'm with you, sir. Yeah, I'm with you. Certainly, I got that.
Yes. So if you want to go from straight away from solid to gas, we call it sublimation. And if you want to go from gas back to solid without passing through liquid, we call it desublimation. So in this one now, only 3 compounds can sublime. They are camphor, naphthalene, and dry ice. Dry ice is an example of carbon dioxide. So carbon dioxide, naphthalene, and camphor, they are the only 3. They are the 3 compounds in nature that can change directly from solid to gas. That is what sublimation. So A, sublimation, B, evaporation, C, diffusion, and D, radiation. What's the answer?
That would be sublimation.
Correct. So sublimation is the answer. Let's go to number 4. Next question. The atomic weight of nitrogen is now when you talk about atomic weight, what you are talking about mass number. Mass number. That's the number of both the number of proton and neuron present in the nucleus of the atom. Do you get that?
Mr. Lumidi. Sorry, sir. Mr. Lumidi.
Yeah.
Okay, I'm really sorry, but since it's just the both of us that are here, I am way past all this level actually. So I don't know if you can just maybe let me answer the questions. Since it's just the both of us, I don't know, or you feel it's necessary that you explain it.
You know what happened? What happened is that it's only both of us that are here. Some people are still coming, and that will be sent to many people. Are you getting it? So that's the reason why I need to explain and break it down for many people that will still look at it later. Do you get it?
Right, sir. All right, sir.
Yeah, you are the only one here, but we are teaching the whole world. Do you get that? Hello?
I do, sir. Certainly, sir.
Yeah. So that's why I need your maximum cooperation also, so that we can both teach them. Now, so the atomic weight of nitrogen. Nitrogen is in group, nitrogen is 2,5. That's belong to group 5 of the periodic table. Belong to the group 5 of the periodic table. So the atomic number is 7, while the mass number is 14. So the atomic weight of nitrogen will be what? Hello?
The atomic weight of nitrogen is meant to be 14. Yes, because correct. It contains should I continue?
Yeah, because
it contains 7 protons and 7 neutrons.
7 neutrons. Good, correct. So number 5, we are going to number 5 now. Now, the maximum electron in end shell is, now in the shell we have K, L, M, and N. K, L, M, and N. The K shell, the maximum number of electrons in the K shell is 2. The maximum number of electrons in the L shell is 8. The maximum number of electrons in the M shell is 18. And the maximum number of electrons in the N shell is 32. So it's always 2, 8, 18, and 32. So the maximum number of electron in the N shell will be what? Will be 32. Is that right? Do you get that?
Yes, sir. Yeah, very correct. Also, you should have.
Yeah.
I'm very sorry. The formula of n square. I mean, is that not where the formula applies? As in the number of shells, yes. Where we have. Yeah, I think that's where the formula applies. Have you?
Yeah. You
n square formula now.
In the first one, in the A, in the
2n square.
Shell, in the K shell, you have only 0, and 0 is having 2 subatomic level. So that would be 1 up and 2 and second one down, according to Schrödinger, the Nebel rule, according to Nebel rule. So 1 up and the 1 down. While in the L shell, you are having -1 is 0 and 1. -1 is having 2. 0 is having 2, 1 is having 2, making 6, plus the 2 of the K, everything making 8. In the M shell, you have -2, -1 is 0, 1, and 2. So each one is having 2, 2. That's what? 2, 2, 2, 2, 2. That's 10 plus the 8 you have before. That's 18. While in the N shell, you'll be having -3, -2, -1, 0, 1, 2, 3. That's 1, 2, 3, 4, 5, 6, 7. 7 orbital. So the 7 orbital, each one is having 2. 2 times 7 is what? 14. So 14 plus the 18 you are having before, making 32. So that's how the 32 comes out. So number 6. Question number 6. The mass number of nucleus is now when the atomic was discovered, the atom was discovered. They discovered that the shell of the atom is having the electron, and the electron is what? Negative charge. While the nucleus is having the nucleus is in the center of the shell, very small but massive, and is having both neutron and proton. The neutron have no charge, the proton has a positive charge. So the reason why you say a shell is neutral is because the positive charge of the proton, the proton positive charge of the nucleus, and the negative charge of the electron, they are both equal, but they are opposite in charge, negative and positive. So that makes it neutral. For example, in the case of that nitrogen that we solved that time, we have 7 proton, which is positive, and 7 electron, which is negative. So that make it what? Neutral. Did you get that? So the mass number of a nucleus, A, always less than its atomic number. The sum of the number of proton and the neutron present in the nucleus, always more than the atomic weight, a fraction. So the answer is B, the sum of the number of protons and neutrons present in the nucleus. Do you get that?
Yes, very well, sir.
Okay, good. Let's go to number 7, the next one. Number 7. The mass of one Avogadro number of helium atom is we know that Avogadro number is 6.02 times 10 to the power 23. Now they're asking for the mass of helium. We know that helium is He. You have 4 at the top and you have 2 at the down. The atomic number of helium is 2 and the mass number of helium is 4. So anytime you are asked for the mass of the mass of one Avogadro number of any element, they are asking for the mass number of that element in gram. Do you hear me? The mass number of that element in gram. That's what they are asking you. The mass number of that element in gram. So the mass number of helium in gram is what? 4 gram. So the answer will be B. Do you get that?
Yes, sir. Yes, sir.
Okay. So when anyone that you don't understand, please let me know. Then we'll go to number 8. Number 8 says 220 grams of carbon dioxide contain dash moles. Now we have 7 formulas for number of mole. Number of mole can be mass over molar mass. Number of mole can be volume over GMV. Number of mole can be number of proton over Avogadro constant. Number of mole can be concentration times volume. Number of mole can be number of electrons over Avogadro constant. Number of mole can be number of particles over Avogadro constant. So we have 7 rules for number of mole. But here we are having mass and the molar mass. So they said 220 grams of carbon dioxide contain dash moles. Now, carbon dioxide is what? CO2. What would be the molar mass of CO2? Carbon will be what? 12 plus oxygen is 16 times 2. So we have 16 times 2, that's 32 plus 12, that's 40, that will be 44. So the molar mass of carbon dioxide is 44. Why the mass of carbon dioxide that we are given is 220. So the formula is number of mole equals to mass over molar mass. So what is the mass? The mass is 220 and the molar mass is 44. So Solomon, 220 divided by 44 is what?
5, sir.
Yeah, so the correct answer is 5. So the number of mole of carbon dioxide contained in that is 5. So do you understand that? Hello,
Yes, sir.
Solomon. Do you understand that? Yeah, good. Thank you.
Yeah, I
So
do.
let's go to number 9. Let's go to number 9. The nucleus of an atom consists of yeah, I've told you this before, that the nucleus of an atom consists of what? It consists of the proton, which is positive charge, and the neutron, which has no charge. So the answer will be C. The nucleus of an atom consists of proton and neutron. So number 10. The process by which salt and water react in a limited way to form an acid or base is the process by which salt and water react in a limited way to form an acid is. Now, they gave us some options. The first one they gave us is neutral process. What is a neutral process? A process whereby water is formed. A process whereby water is formed. But in the case of the question, water is used up, water is not formed. Then we have the B is basic acid process. Basic acid process is same thing as neutralization, the reaction of acid with base to form salt and water. Then the C is talking about hydrolysis. That's the process by which a compound dissolves in water. A compound dissolves in water to form to give a product. Then the D, we have the sublimation. That's movement from solid to gas directly without passing through liquid. So this one is talking about, they said the process by which salt and water react. That means the salt dissolves in water to now form acid and base. So that process is what? Hydrolysis. C. Hydrolysis. C. You get that?
Yeah, I do, sir.
Okay, good. So let's go to the next slide. So those are the questions. The one that we answer, they are all the questions in the 4 topics in 2022. In 2021, sorry, 2021. So this one is from 2020. 2020. Question 1 from 2020 says the electronic configuration of an element is 1s2, 2x2, 2p6, 3x2, 3p3. And he said, how many unpaired electrons are there in the element? Now, according to Nearby principle, it says that when you want to arrange an electron in an atom, that you need to first arrange singly first. You arrange in the 1, 1, 1, 1 first before electron pairing start taking place. The electron will first be arranged singly first before electron pairing start taking place. So for the 1s2, the maximum amount of electron in the s orbital is 2. So that one is complete, 1 up and 1 down. For the 2s2, it's still s orbital. That one is also complete, 1 up and 1 down. For the 2p6, the maximum electron in the p orbital is 6. And so they gave us 6 already there, 2 pieces, 2 here at the first one for the s orbital, s of it, 2 here for the p y of it, and 2 here for the z of it. So it is complete. In the next one, 3x2, you have the complete one, 1 here down and 1 here up. But for the last 3p3, p will always have 6. So you have to first put all the one that you have to first put them singly first. Electron will first occupy the generated orbital singly before electron pairing start taking place. That is Paul's exclusive principle. Paul's exclusive principle states that electron will first occupy the generated orbital singly, one by one, before electron pairing start taking place. So that means we have 3 now. We now put 1, 2, 3. So that's all. So now the question now says, how many unpaired electrons are there in the element? So we have 3 unpaired. We have 3 unpaired. So the answer is C. Solomon, do you get that?
Yeah, certainly I do, sir.
Yeah, good. So let's go to number 2. Which of the following can be obtained from fractional distillation? Which of the following can be obtained from fractional distillation? A, nitrogen from liquid air. B, sodium chloride from seawater. C, iodine from solution of iodine in carbon tetrachloride. Then D, sulfur from solution of sulfur in carbon disulfide. Now, let me give you some, like B. In B, sodium chloride from sea salt, that can be gotten, you can get that one by evaporation. If you evaporate the seawater, you get your sodium chloride. That's by evaporation, not fractional distillation. Then iodine is sublime. So iodine from the iodine in carbon tetrachloride, you can get iodine by sublimation method. While sulfur from the solution of sulfur in carbon disulfide, when sulfur is in carbon disulfide, you can also get that one. You can also get that one. But the A, nitrogen from liquid air, is only what you can use for that is fractional distillation. What do you use fractional distillation for? For mixture that has different temperature, that have different boiling point, mixture that have different boiling point. So what will happen is that when the first one boil, the vapor will go out and you will collect it from the condenser gas and you will make the rest of it. So nitrogen from the liquid air, nitrogen will be taken from the air because nitrogen is what? What's the molecular mass of nitrogen is what? That's 28. You know, N2. Ordinary N is 14. So N2 will be what? That's 40. N2 will be 28. N2 is 28. Why the liquid air is oxygen, O2, and that is 32. 16 times 2, that's 32. So 32 is more than 28. Do you get that now? So when they boil, 28 will first get boiled and move out of it, then leave the 32 alone to get out. So nitrogen from liquid air is the answer. Do you get that?
Certainly.
Yeah. So number 3, which of the following substance is a mixture? Which of the following substance is a mixture? Now, A, granulated sugar. Granulated sugar is just sugar, the same thing as sugar. Your sugar in organic chemistry, the seawater. Then you have your sodium chloride. Your sodium chloride is a compound, NaCl. Your ion filling is an element, Fe. Why your seawater is a mixture. Your seawater is a mixture. It contains it contains particles. It contains salt. It contains water. So your seawater is a mixture. Next question. Number 4. 4 elements. Sorry. 4 element P, Q, R, and S. 4 element P, Q, R, and S have atomic number 4, 10, 12, and 14, respectively. Which of these elements is noble gas? Which of these elements is noble gas? Now, in the periodic table, we have group 1, 2, 3, 4, 5, 6, 7 to 8. The group 8 is a noble gas. Group 8, we call them noble gas because they don't react. We call them, they can either be called noble gas or red gas because they don't react. Why they don't react is because, do you know the reason why they don't react? Hello, Solomon. Hello,
They
Solomon.
don't react because they have obtained their octet and duplex structure.
Yeah, correct. Thank you very much. So the reason why every element reacts is because they want to complete either the duplex 2 or the octet structure. So group 8, the group of helium, which is the noble gas, they already complete their 8. So you don't need anybody, they don't need any reaction again. So that's why you don't react. So let's now see from this, which one is in group 8? The P is 2, 2, is in group 2. The Q, 10, is what? 2, 8. Then the R, 12, is what? 2, 8, 2. That one is in group 2. Then the X is 2, 8, 4. That one is in group 4. So the 10 is in what? Group 2, 8. That's group 8. So the answer is 10. And the 10 is
Yeah,
what?
I got it, sir.
So the answer is B, Q. Did you get that? Yeah, good. Number 5. How many valence electrons are contained in the element? It is 15 superscript. No, sorry, 15 subscript, 31 superscript, and P. You get it? That's P 31, 15. Now you say how many valence electrons are contained in the element? So what can we use to know the valence electron? You are going to use the 15. So from the 15, we break the 15 down. So 15 is 2, 8, that's 10, 5. So that means it belongs to the group. It belongs to the group 5. But group 5 can have two types of valence electron. It can have 3 valence electron, because group 5 means that is either you are leaving the 5, that's +5, or you are collecting 3, that's -3. Do you get that? Group 5 means that when you are in group 1, it means that you are losing 1, that's +1. When you are in group 2, that means you are losing 2, group 2, that's 2. When you are in group 3, you are losing 3. Are you getting it? But in group 5 can either gain 3 electrons to complete or lose a 5 electron. So the valence electron in that 1531 is 3. 3A. Do you get that?
Yes, sir.
Hello. Yeah, good. So let's go to the next question. The next slide. Okay, this one is from 2000. This one is from 2018. No, 2019, sorry. 2019. It's 2019 question. Question number 17. 2019. Question number 17. Which of the following statement does not show Rutherford account of nuclear theory? That an atom contains a region. Now, in the Rutherford explained the whole atom. He said the atom itself is is a space, very big space, negligible space, meaning that there are many places that are just space, nothing is present. I now said on that atom, at the shell of the atom is the electron that are what? Negative charge. Then they said there is one part in the middle of it that is called a nucleus. That nucleus deflects. Anything that comes to the nucleus, most of it are deflected at the nucleus. Many things that come to. Now the nucleus is positive charge because it has protons that are positive and the neutrons that have no charge. So let's look at what they are saying about the atom here. So A, which contain proton and neutron, that is correct. A is correct. It's going to say which of the following statements it does not show. So A shows Rutherford account, which is positive charge, yes. The nucleus positive charge is correct for Rutherford account, which is massive and can cause deflection of few projectiles, no. D, which is very large and in which close to 98 of the projectile pass undeflected, yes. Now, the D says that many of the particles that pass through the atom, they are undeflected, but those that pass through the nucleus itself, they are deflected. So C is the answer. C is not correct. It's not Rutherford. Rutherford did not say. Rutherford says it's massive, but it cannot cause deflection of a few projectiles. It causes deflection of many projectiles. So the answer is C. Do you get that?
Yes, sir.
Okay, so let's go to number 18. Elements S and Y have electronic configuration of 1s2. So we have the X that is having configuration of 1s2, 2s2, 2p4, and Y that is having configuration of 1s2, 2x2, 2p6, 3x2, and 3p1. So now, if I want to know the group of X, all I will just do is that I will go and find the orbital, and any number on the orbital, the greatest orbital is my group. For example, now S belongs to what group now? If you look at the last orbital. Hello, Solomon. X belongs to what?
Yeah, I didn't get that question. S is group 1. S is group 1 and 2. P is group from 2 to 8. Then the D is from. Okay, should I continue?
No. That's not what I'm asking you. What I'm asking you now is that from 1s2, 2s2, and 2p6, can you say the group that that element X belongs to?
Okay, let me go through it. Please give me a minute. I'm going through it. So the elements belongs to group 3. because the outermost shell will contain 3.
In the S, okay, let me show you what
That's
next time how
3s2
you answer that
3p1.
question. Now the first one, the X, is having 1s2, 2s2, and 2p4. Now you are going to look for the highest number. The highest number is 2 and 2. That's 2 here. You are going to look at the number on those two. You are going to add the number. That's 6. So group 6. You get it? 2 plus 4. That's 6. X belongs to group 6. And you will come for this also. The highest number here is what? 3, 3. So you add the 2 on top of this plus 1 on top of it. That's 3. So that means Y belongs to group 3. S belongs to group 6. And Y belongs to what? It belongs to group 3. Now, when you have anything in group 6, it means that it wants to collect 2 electrons to complete. That would be what? -2. Do you get that?
Yeah, I was sorry. I didn't see the question very well. I'm very sorry. Yeah, I got this now.
Yeah. So, and when you have elements in group 3, that means it wants to lose the 3 electron after electron, and it will do what? +3. Now, what you just do is that just do cross multiplication. S will go and meet 3, and Y will go and meet 2. So you'll be having Y2, because Y is the metal. Y2, X3. Metal will always come before non-metal. So you have Y2, X3. You have it there. Yeah, we have a C. You get the question?
I do now, sir. I do.
Yeah, good. Thank you. So let's go to number 20. The combustion of carbon 4, carbon 2 side in oxygen can be referred by the equation. We have 2CO plus O2 plus 2CO2. Now, calculate the volume of the resulting mixture at the end of the reaction if 50 cm³ of carbon 2 oxide was exploded in 100 cm³ of oxygen. Now, we have the rule that we call Gay-Lussac law of combining volume. We state that when gases react, they do so in volume ratio, which are in simpler ratio to one another and to the volume of the product formed, provided temperature and pressure remain constant. So what is Gay-Lussac saying is that when you look at if you look at the 2CO, the 2 at the back, you call it volume. That means the volume of the CO is 2. And when you look at the O2, it's having just ordinary 1. You call the volume of the O2 1. And if you look at your product, 2CO2, that's carbon 4 oxide. You call the volume, because it's having 2, you call the volume 2. So that is what it's saying, that when gases react, they do so in volume, which are in simple ratio to one another, and to the product form, provided the temperature and pressure remain constant. So the CO is having 2, the O2 is having 1, and the CO2, the product, is having 2. So he said, calculate the volume of this resulting mixture at the end of the reaction if 50 cm³ of CO. So you come on that 2, you put on that CO, you put 50 cm³. Was exploded in 100 cm³ of oxygen. You come on that oxygen, you put 100 cm³. Now, this is the golden rule that you are going to use, the style you are going to use. Now, 50, if my 2 is 50, my 1 will be what? Will be 25. You cannot go the other way, that if my 100 is 1, if my 100 is 1, my 2 will be 200. And we cannot find 200 in 50. So you cannot go that way. But if my 50 is 2, then that means my 1 can be 25. You can still see 25 in 100 cm³ of oxygen. That means what we'll be using by CO is the total 50 cm³. But what we'll be using by O2 is 25 cm³. So the CO that will remain will be what? Is 0, because everything is used up. But the oxygen that will remain will be 75 cm³, because only 25 cm³ is used. Now, if you look at the reaction, the CO2 is having 2. So if 50 is 2, then the 2 will be what? Also, then the CO will also be what? 50. So 50 cm³ of product formed. So that means it will now be addition of the product formed and the unused. They said calculate the volume of the resulting mixture. Resulting mixture means what? The product formed and the unused. So the product formed is 50, the unused is 75. So everything will be 125 cm³. That's number B. Do you get the question?
Yeah, I do, sir.
Okay, good. Next question. So number 21. We are still 2019. 21. When ammonia and hydrogen ion bond together, they form an ammonium ion. That's NH3 plus H plus. They form NH4 plus. The bond form is called, now, we have two types of bond. We have the ionic or electrovalent bond, and we have the covalent bond. The ionic bond is formed when there is movement of electron from the metal to the non-metal. That means just transfer of electron. For example, if you have NaCl, N is having +1 and Cl is having -1. So N is leaving its own one electron to go and give Cl. So that is electrovalent or ionic bond. So in that one, the electron is transferred from one atom, which is the metal atom, to the non-metal atom. The second one, we have the covalent bond. In covalent bond, there's sharing of electron. There's no transfer. But the sharing of electron can either be brought by only one of the two compound or the two substance, or can be brought by the two of them and they share it. You get that? So when it is just transfer, when it is brought by just only one, then it is called ordinary covalent bond. But when it is brought by the two, I bring my own, you bring your own, and we share together, then it is called dative covalent bond. So now, so this one says, now we have NH3 plus H plus. H plus is having one electron that you want to give out. NH3 is having one electron that you want to give out. So at the end, both of them react to form what? NH4 plus. So NH3 is giving, H plus is giving. So there's no transfer of electron from one to another, but there's sharing of electron. They both share. So the answer is what? Is covalent bond. Covalent bond. That's it. You get that?
Mr. Olumide, I'm very sorry. I think you gave I think it's supposed to be a dative covalent bond in ammonium ion, because the the hydrogen is coming to pair up with the valence electron in the nitrogen from the ammonium. So it's supposed
Yeah.
to be a
Eh,
dative covalence bond. Do you
yeah.
understand me, sir?
Yeah. Dative covalent bond is an example of covalent bond. Yes or no?
Certainly, sir. Certainly.
Yes. So now look at the question. Look at the option. What is your A?
Electrovalence bond,
Your
compound bond,
B?
which is nothing.
C?
Compound
C is what?
ionic bond is the same as electrovalence bond.
Then D is what?
Okay, covalent. Okay, so yeah, I get
So
it. I got it.
so don't go and don't make the mistake. Dative covalent bond is an example of covalent bond. Are you getting it? So here they are not giving you either ordinary covalent bond or dative covalent bond. So the answer is D. So you get it
Okay.
now. Do you
Yeah,
get it
certainly.
now? Yeah. So let's go to number 22. Which of the following represent the kind of bonding present in ammonium chloride? Which of the following represent the kind of bond present in ammonium chloride? Now, what form ammonium chloride is? NH4 plus Cl minus. Now, ammonium chloride, ammonium itself, NH4 plus itself, is formed by what? Covalent bond. Now, but now, when NH4 plus is missing with Cl minus, the plus from the NH4 will be transferred to the Cl. The Cl will take it. That's what? That's ionic bond. Are you getting it? So they become NH4, Cl. So two types of bonding occur in NH4Cl. The first one is what? Is the covalent bond, and the second one is, the first one is dative covalent bond, which is covalent bond, and the second one is what? Ionic bond. So the answer is C. Do you get that?
Yeah, yes, sir.
Yeah, good. So we'll go to 2018. We're 2018 now. 2018. A given amount of gas occupies 10 dm cube at 480 m and 273 degrees Celsius. Now, volume is what? 10 dm cube. Pressure is what? 480 m. Temperature is what? 273 degrees Celsius. The number of moles of the gas present is, that's number of mole. You know, I told you that time, the number of mole is what? Volume over GMV. GMV is granular volume, and that's 20.4 dm cube. At STP is 20.4 dm cube. So now, because we are dealing with gas now, 10 dm cube, you know, a given amount of gas occupied 10 dm cube. Because we are dealing with gas, that would be 10 times 2 all over the granular volume, which is 22.4. 20.4 dm cube. So you'll be having 10 times 2 is 20 over 22.4. What is 20 divided by 22.4? Hello, are you
there? I didn't get you, sir.
Hello? 20 divided by 22.4 is what? 20 divided by 22.4.
Hold on, I have to use a calculator. Hold on.
Okay, let me press calculator from here then. So I thought you were with your calculator. That's 22.4.
That would be 0.89, sir.
Yeah, that's A. 0.89 mole. That's it. Good. Number 6. That's the second question that we. Number 6. It said the type of bonding in Cu NH3 4 then 2 plus is the type of bonding in Cu NH3 4 2 plus is the type of bonding in Cu NH3 4 2 plus. So we have A, coordinate bond, B, electrovalent bond, C, metallic bond, D, covalent bond. Another name for dative bond is what?
Coordinate bond.
Yeah, coordinate bond. Good. So the answer is what? A, coordinate bond. Number 7. So now let me explain all these bonds for you one by one, so that at least when you get them, coordinate bond, we always coordinate or dative covalent bond. We always end with an ion. That's either 1 plus, 2 plus. You get it's always okay. It produces a radical. You know what they call radical? Radical is a compound that, yes. So coordinate or dative produce a radical. Electrovalent produce just ordinary compound. Are you getting it? Compound that they share electron before forming it. Why the metallic bond, the covalent bond is transfer of electron, while the metallic bond is a bond between the ions of metal. Very to be strong. So now, number 7. Which of the following is an example of a chemical change? Which of the following is an example of a chemical change? Which of the following is an example of a chemical change? Now, with physical change, in a physical change, it can never change back again, turn back. Oh, sorry. In a chemical change is irreversible, while physical change is reversible. For example, now, if I put my salt in water, I can still evaporate it to get my salt back. That's what? That's a physical change. While a chemical change is irreversible. If I burn my firewood now, it turns to ashes. Can I get my wood from the ashes back again? No. So no, that's a chemical change. So let's look at all this one. Let's look at the one that cannot be gotten back again. the solution of salt in water, can I get my salt back again?
Yes, you can get your salt back.
Yeah, by evaporation. Good. The
Yeah.
separating mixture by distillation. Yes, it's separation, so I can get it back again. Melting of ice. Can I get my ice back again?
Certainly.
Yeah, when I freeze it, I get my ice back
Yeah,
again.
you feel
But rusting of iron, when my iron rusts, can I get back the iron again from the rust?
not easily, sir.
Yeah, I can't get it. So that's chemical change. So rusting of iron is chemical change. Next question. Methanoic acid mixes with water in no proportion and has about the same boiling point as water. Look at that place. Methanoic acid mixes with water in no proportion. So that means they mix together, they become one. And they have the same boiling point. If they have different boiling points, then we use fractional distillation to separate it, because fractional distillation is only used for miscible liquid that have different boiling points. But this one now mixes with water in no portion and has about the same boiling point. So you cannot separate them by boiling point. Which of the following method will you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? A. Extractive distillation. B. Filtration followed by distillation. C. Neutralization with sodium hydroxide followed by distillation. D. Neutralization with sodium hydroxide followed by filtration. Now, let me explain everything to you one by one. If you choose B, filtration followed by distillation, when you filtrate, the sand will go away, you have your water and methanoic acid. You cannot distillate water and methanoic acid because they have closely approximately the same temperature. So they are, both of them will go into it. So you can't separate them. Now, neutralization with sodium hydroxide. If you put sodium hydroxide in the acid, it forms salt and water. They're followed by distillation. Now, you have your salt already. You have your salt, you have the water again, then you have the sand. So it cannot be separated by distillation. Then neutralization with sodium hydroxide followed by filtration. So the same thing happened to them. So the answer is extractive distillation. Extractive distillation. Extractive distillation. Extractive distillation is used when you have when you have substance, miscible liquid that are of the same miscible liquid that are of the same temperature. So extractive distillation means that you are extracting. So you just extract the methanoic acid from the water. So it will leave the sand alone. Do you get that?
Yeah, yes, sir. But I was thinking because I am aware that since we have methanoic acid,
Yeah.
COOH, and then sodium hydroxide, by the time we neutralize those two, the sodium hydroxide and the methanoic acid is neutralized from the solution, and then we can
Yeah.
filter the sand out for option D. So I was thinking that that would have been.
Yeah, you
I
can
don't really
filter the
understand that
sand. You still
extractive
have the salt and
distillation.
water. You still have the salt and water.
Okay.
That's
I'm taking that.
if you mix the acid and the base together, it forms salt and water. So you still have the salt inside the water and sand. So it would have been that if, assuming they said filtrate and distillate. Do you get that?
Okay,
Hello?
okay, sir.
So
Yes, sir.
they know what. So the extractive distillation is a compound. Is a compound distillation that will remove the metabolic apart, will remove the water apart because they have the same temperature, boiling point. And when it's removed the two of them apart, it will remain the sand inside it. So do you get that?
All right, sir. Yeah,
Yeah,
that's
yes, I love the way you respond. That's very good. It shows that yes, you are really studying very well. I love that. I like to have students like you. So number nine. Number nine. The number of electrons in the valence shell of an element of atomic number 14. The number of the electron in the valence shell of an element of atomic number 14. So let's look at number 14. Atomic number 14. So atomic number 14. That would be 2, 8, and what? 4. 2, 8, and 4. Is it 14? Yes, that would be 2, 8, and 4. So the valence electron will be what? 4. Do you get that?
Yes, sir.
Yeah, good. So 2000, then, so number 10, I think we move out from 2008, 9. Okay, you are still in 2018. What volume of oxygen will remain after reacting 8 cm3 of hydrogen gas with 20 cm3 of oxygen gas? So it's still Gay-Lussac law. It said what volume of oxygen will remain after reacting 8 cm3 of hydrogen gas with 20 cm3 of oxygen gas. So let's write the equation. Hydrogen H2, 2H2 plus O2 equals to 2H2O. So what do you have? The Avogadro volume. This one is 2. The hydrogen is 2. Oxygen is 1. And the water is 2. So 8 cm3 of hydrogen. So under the 2, you put 8. Under the oxygen, which is 1, you put 20. So let's now look at the reaction now. If 8 equals to 2, 1 will be equals to 4. We can get 4 in 20. If 20 equals to 1, 2 will be equals to 40. We cannot get 40 in 8. So we are going to go with the first one. If 8 equals to 2, then 1 will be what? 8. It will go 4. So that means the volume of oxygen that will be used up is 4 cm3. So 20 minus 4 cm3 is what? 16 cm3. So what was the question? The question says, what volume of oxygen will remain after reacting? So remain. The volume that will not be used. So the volume that will not be used is what? 16 cm3. Do you get that? Hello, Solomon.
Yeah, yes, I got it, sir. I got it.
Yeah, okay, good. So the volume that will remain is what? 16 cm3. So next question. So the next question, we have number 31, still the same here. What is the concentration of solution containing 2 grams of sodium hydroxide in 100 cm3 of solution? What is the concentration that we are looking for? Concentration, we don't know, of a solution containing 2 grams. So mass is 2 grams of sodium NaOH in 100 cm3 of solution. What is the concentration of solution containing 2 grams? So of NaOH in 100 cm3 of the solution. So the mass of sodium hydroxide is 2. We have the mass is 2. So we are looking for the concentration, and the molar mass of NaOH is Na is 23, O is 16, and H equals to 1. So NaOH will give us what? 23 plus 16 plus 1. That would be what? That would be 40. Yeah, 23 plus 17, that's 40. So the molar mass of sodium hydroxide is 40. The mass is 2. So we can say number of mole of sodium hydroxide, that's NaOH in the solution, will be mass 2 over 40. And what is 2 over 40?
0.005. 0.05.
0 point what?
05. 0.05.
So now that is the number of mole. So, and the number of mole equals to what? Concentration times volume. Concentration times volume over 1000. If you are given cm cube, since this volume is in cm cube, we are going to divide by 1000. But if this volume is 1000, so that means we have 0.05 equals to concentration that we are looking for times volume, which is 100 over 1000. So cross multiply 1000 times, so that would be 1000 times 0.05 over 100. So that would be this 20 cancel to 0. That would be 10 times 0.05. that will be 0.5. That will be 0.5 mole per dm3. That's option B. Do you get that?
Yeah, yes, sir.
So next one. How many atoms are present in 6 grams of magnesium? How many atoms are present in 6 grams of magnesium? Now, they've given us mass. So number of mole of mg equals to mass over molar mass. So mass is 24. No, mass is 6 grams. Then the molar mass of magnesium is 24. So 6 divided by 24 will give us what?
0.25.
Is 0.25. So that's the mole. So 0.25, which is number of mole, equals to number of atom over Avogadro constant. So that will be 0.25 equals to number of atom we are looking for over Avogadro constant is 6.02 times 10 to the power 23. So we must multiply. So we have 6.02 times 0.25. That will give you what? What's 6.02 times 0.25?
1.51
Yeah, that's 1.51 times 10 to the power 22. 1.51 times 10 to the power 22. Good. So that's the answer for that one. So next slide.
Hello, sir, are you there?
Yeah, the next question, it says the shape of S orbital. The shape of S orbital. We have S, P, D, and F. S, P, D, and F. The shape of S orbital. You know S orbital?
Yes, sir.
Yeah. So the shape of S orbital, it is spherical. Spherical. That's the shape of S orbital is spherical. So what's the shape of P orbital?
Spiral, dumbbell.
Yeah, dumbbell shape. Good. Dumbbell shape. So the answer is what? S orbital. The shape of S orbital is spherical. So number 2. The shape of ammonia molecules. No. That one is not part. This is sorry. This number 2 is under organic
Shapes
chemistry.
of molecules, shapes and molecules. Yeah.
It's under organic chemistry.
Although the answer would have
Yeah, it's under organic shape and molecule of organic
A,
chemistry. But this
planar.
S orbital is under, this one is still under our division. Yeah, I know. The answer is trigonal planar. I know it's trigonal planar. The shape of ammonia molecule, I know it's trigonal planar. But we are still going to go into that one. Maybe in the last, that will be the last topic. Organic chemistry will be our last topic. So number 3. An oxide of SO2 has a vapor density of 32. What is the atomic mass of S? An oxide SO2 has a vapor density of square root of 32. What is the atomic mass of S? So the relative molecular mass equals to relative molecular mass equals to vapor density times 2, and vapor density equals to atomic mass. Do you get the formula?
Yes, sir.
Yeah, relative molecular mass equals to vapor sense times 2, and vapor density equals to atomic mass. You get that? So in this question, outside of SO2 has vapor density of 32. What is the atomic mass of S? It will still be 32. But assuming we are asked to find the relative molecular mass now, it will be what? 64. So the answer is 32. That's B. Next slide. Oh, this is the end of the slide here. Oh, hello.
It's been a wonderful time, sir. Thank you very much, sir.
Yeah. Oh yeah. So I prepared. Normally, I prepared this for larger students. I know they will have many questions to ask.
Yeah,
So, and I think so. So because it's between me and you, that's why it goes very straightforward and we got everything. So I believe you have learned many things. Hello.
yeah. You have been able to put me through one or two.
Okay. Okay. So anything you want to ask in this topic?
No. That's
Okay. Okay. Okay, don't worry.
although this is the
So
first time I'm
what
hearing
we're going
that
to
word.
do is, you said what?
I said, although this is the first time I'm hearing that extractive distillation, though, but as soon as I drop, I'll go check it.
Okay. So what we do, what I want to do for the chemistry class, because I'm the one also taking biology. Are you doing biology?
No, I'm not doing biology. I'm doing physics, chemistry.
Okay, you are an engineering student. Okay. So what I want to do for the chemistry student is that I'm going to divide the whole chemistry into four. I'm going to
All
divide the
right,
whole
sir.
chemistry. Yeah. So this is the first part. So next one will be like 8 topics instead of these 4 topics. So next one will be like 8 topics that we meet. So it's nice meeting you.
Yes, sir. And you too,
So
sir.
I believe that you read your book very well and you do very well. So have a nice time.
Thank you very much, sir.
Yeah. Bye.